Hello everyone, my name is Pradeep Kumar Yadav. I'm a physics faculty for ITJE NEET. I have nearly 9+ years of teaching experience. So today we are going to talk about a very fascinating topic, a very basic, very fundamental work power energy. Uh, these are the very important concept because without understanding of a proper idea about these concepts we cannot talk about the more complex things, right? More complex thing will be felt more complex because you have some gaps in the fundamentals. So we will try to make sure that we should see the complete picture of those fundamental concepts, because if you will understand those things in proper manner, then the other concept discussion will become more smoother, that those concepts will take less time to get and grasp, to understand, right or not. So further coming discussions will become more and more smoother for that. So what I believe, for during discussion of this fundamental concept, we should take whatever the time is required for to give to create a proper clear understanding about these concepts, right? So generally I take more time little bit because in comparison to those usual concepts, so just be with me in with this, right? And let me show you how beautiful these concepts are, right? Okay, so let me share the screen. I hope it's now visible. So let's talk about the one of the greatest and important concept, energy. Okay, so energy is not a new term, right? Not a new term for you. Uh, Basically, without studying the physics in previous life, whatever we have spent in our past, right? So in those duration also we have used this term in our day-to-day life. We are very well aware about these terms. We are very used to with these terms, right? So we have some basic idea. We have some idea from our experience that what the energy means basically, and what the work kind of term have meaning, right? So I'm not going to talk about the definition. What we have a general idea about the meaning, about the energy, the same idea, the same meaning also we are going to use in the physics also. So we will try to discover what the energy was basically in our day-to-day life. So let's talk about some event, some examples, some situations when we have coined from our side this term energy, or someone else was during conversation with you coined this term energy. So what he was having meaning after using this term energy, right? So let's figure out those moments, scenarios, right? So energy, yeah, I'm getting event. Everyone have experienced the marriage parties, right or not? Everyone have experienced that, and everyone have seen someone was dancing on the stage. Let's say he was drunk also. Someone was dancing very vigorously and for a longer duration of time. So just by observing that guy from the crowd, someone will definitely come and say, "Oh, that person looks very energetic," right? Just because he was dancing very fast and for a longer duration of time. Let's talk about the similar case, like if someone is running on the track and running very fast, right? And running very fast, and with the same speed, he, let's say, completed his one complete cycle of that track. Let's say a track is having nearly 400 meters. He have completed his 400 meters with the same speed. Now he is going to enter into the next cycle with the same speed. Then again, what will you say? From the crowd, everyone will start cheering up. Okay, hey, that person is very energetic. He is continuously running for a longer duration of time in this same manner, right? Let's talk about another cases, situations like I'm teaching in the class. Let's say I'm teaching in the class, and from the morning, and now continuously I'm teaching, and now it's going to be evening. Just without taking heavy breaks, some let's say you can say 15 to 20 minutes breaks, then again you will say that, okay, sir, you have a tremendous huge energy to teach, actually, right or not? What is the common all in all these phenomenon or the events? We can say the common thing is, in every situation someone was doing something, and doing something very hard, right? That's why you were forced to say, okay, that person looks very energetic, right or not? Someone was doing very hard then. Okay, let's talk about one more situation. When that person was running, after sometimes, if you will see that person is losing his speed gradually, what will you say then? You will start saying that, oh, now that person looks less capable to perform that activity. The person looks now tired, right? So you are indirectly you are saying the person is now having low energy left, now less energy left, right or not? Because he have done that activity for longer duration of time. He is no longer to perform that activity anymore further, right? So his energy is lost now. Why you are saying this energy? Because you are saying he is no he lost his ability up to some extent to perform that activity, right? And whenever he was having that ability to perform that activity, you were saying that person looks very energetic, right? The same meaning is in the physics also. What is you have already studied in the class ninth level also, right? What the basic definition, I hope everyone have this uh, everyone have seen such kind of definition. What was that? Ability to do work. It's not a new definition for you, but I hope now you can get why such kind of definition is there. Because what we understand in our day-to-day life, the same, right? Ability to perform some activity, ability to perform do some stuff, right? If you have more ability, you will be considered as more energetic, right? Or not? Like in morning, you wake up, you feel fresh, you feel that now I can do lots of things for longer duration of time, right? Or not? Like you feel fresh to study in your class, right? Or not? uh, you feel fresh, and you feel that you can study for coming 2 to 3 hours without any problem, right? So you feel able to do those activities for longer duration of time, means you feel energetic, we can say simply, right or not? So energy is what? The ability to do something. Here we are going to talk about ability to do work, but in physics we will not talk about generally about living beings, we will talk about non-living things. Okay, so how non-living things can be can also be energetic? Yeah, to be energetic for human beings or for any being makes sense. But for non-living things also energy, we are going to talk about energy of that non-living things. Yes, yes, of course. Why? Because it is just about ability to do something, right? So non-living things also can do lots of things, but if you will see what they are doing in day-to-day life, so you will find that non-living things are just at rest, or they are moving here and there, and in that they are applying some forces, push and pull, such kind of activities are also involved. So they are also doing, definitely that is very fundamental activities, but they are also doing. So we can imagine some energy association with those non-living things also, right? Okay, so we understood what the energy here. Okay, I will not only this, I will show some examples. I will ask some questions also to go a little bit much more detail. You can think of what detail left here to talk. I will show you, right? Okay, now let's talk about work. Okay, what is work here? Work have a very special property that if after doing some work you find yourself burned out, you find yourself drained, means energy is not um, that much whatever was present before doing the work, right? So work is some activity in which you are involved. After continuously performing that activity, you will find that your energy is lost, right or not? So whatever activities which takes your energy, right, with the time, that activities are basically a kind of work for you, right or not? So in day-to-day life we have the same meaning. So here also for non-living things also the same meaning we are going to coin here. So we have to just see what kind of activities will be considered as work for the non-living things. Only those, after performing that activity, that non-living thing should look little bit less energetic, then that activity will be considered as work for that non-living thing also. So with the observations we found some particular activity basically. Let's me write here in layman way what kind of activity. It is some kind of activity in which I'm not talking about in mathematical manner. I'm just expressing so that a layman can also understand initially, right or not? A little bit slowly, I will go a little bit in detailed and more precise manner, right or not? So activity in which something or someone forces some other thing, right? Some other thing and causes, this is very important, and causes displacement. We found thus this simple activity in which someone is forcing something other, some other kind of thing, and due to that force, displacement should come. After this only we observe that non-living thing is not no longer to capable to perform the same activity again on something else after performing some portion of activity, some duration of activity, like this, right? If someone is forcing and causing displacement, we got the idea, okay, this particular activity is worth of work, right, for non-living things. So energy is nothing but then energy is just ability to force and cause displacement for the non-living things. Okay, I will show you that how, why the forcing and causing displacement becomes work here for the non-living things. I will show you that. Okay, so this is one way to see the work as a point of view of activity. And some other scientists or some other observers, they also see the energy a kind of mod, a tool, a way to control the energy, right? So it is a mod. It is a mod to change, to create some kind of change, right? To create some kind of change in energy. Like I said, if you will do work in your day-to-day life, so you will feel drained out, right? Some energy is drained. That you feel that energy is now less in you, right or not? So words are responsible to change the energy, and I will show you it. If some non-living things will do some work, so that non-living thing will lose its energy, but it looks after some time you will observe. So you will find that over which the work have been done, that things have energy more now, right? So it looks like the energy from one body shifts to the another body, and sometimes you will see that energy is not going anywhere from one body, it is just changing its form. Or we will talk about that later, little bit, right? Okay, so you have understood what kind of activity is going to be considered as work for non-living things. Activity in which someone will force and cause displacement. Whatever have ability to force and cause displacement, that thing will be considered as energetic. You understood this much. Okay, now let's talk about some example then. I'm considering a non-living thing in my hand. This mobile is what the non-living thing, of course. I'm taking this non-living thing in my hand. This is a state, this is a situation in which this non-living thing is present, right? Yeah, if it is not going to be present in my hand, so it will be somewhere else. But let's say, as I told you, non-living things can be at rest or they can move here and there only, right? So now in this moment, the this non-living thing is at rest. Is it energetic? Simple question. Is it energetic? So you have to think that, is it having ability to force and cause displacement? Yeah, it is forcing. Of course, it is forcing on my hand. You can see that. But with the maintaining this situation, the maintaining the rest condition, can it can be it can cause displacement also. Let me talk about some examples else. Like if I'm going to take a brick and over that I am going to put a brick, and both the bricks are going to be placed somewhere in the corner of the room, right? Now just close the door and I'll go outside the room. After 10 days, after 10 days, if you'll come, so what will you find? The bricks are going to somewhere else. That one brick is applying the force, but with that situation, with that state, that non-living thing can force and cause displacement. Means that other stone or that brick will go somewhere else. Based on your experience, tell me. You will say, so no, sir. Just by the placing those stationary big bricks somewhere in the corner, yeah, of course, one brick is applying force on the other, but we will never find displacement after such kind of interaction between those two. in which one brick is stationary, other is also just placed over that. So you will say, no, sir. And we will never see that, not after 10 days in our coming life, we will never see that one brick will go somewhere else. So then what will you say? Okay, you will say that, okay, sir, so just by maintaining at the rest, it cannot cause displacement. Yeah, it is able to apply force. So what will you say? It is not able. You will say it is not energetic. Yeah. Okay, we understood just by observation, some observation. So you are saying that it's non-energetic. Then when will it be having some energy then? One state you have observed at rest, it is not having energy. Okay. So when will it be having? Okay, I will say, if I will throw towards your face this mobile, would you like to come in front of this moving thing? Would you like to come in front of moving train? What will you say? You will say definitely no, sir. Why? Because it's very dangerous. That moving train can kill me, right? Okay, now let's go a little bit in technicality. What basically that moving train will do with you? You will say, sir, my hands, it will just break my body into several pieces. One piece of will go somewhere else, another piece will go somewhere else. That's why I don't want to come in front of moving train. Similarly, if I will throw a ball, so you would not, you will not come in front of moving ball, because it can harm. It can take your nose from this place to that place. So you can see clearly, right? You don't want to come in front of moving bullet also. Why? Because they are able to force and cause displacement, right or not? Moving things can do such kind of things, definitely. So yes, so what we will say, as we have discussed, the two states are there. They can be at rest or they can be in moving states. So you said, so at rest, that object wasn't having any energy. It is able to force, but not able to displace with that force. But moving things can do, right? Okay, that's completely a good observation. Moving things can do so, but if you will go a little bit detailed in the chapter, you will find there are two kinds of energies. As you have seen, there are two states, and one of the state is non-energetic, another state is energetic. So why there are two kinds of energy? Basically, there are two kinds of terms. If you will see, there is kinetic energy and there is potential energy. Of course, you have studied in the class 9th also, right? You have heard that. And you know what is the meaning of kinetic energy? It is something, energy associated with motion, right? Again, I'm saying all what I'm discussing, that is for layman to build some layman understanding from your experience, what you have experienced in your day-to-day life, right? After building such base, over that I will build other important concepts. So I take some time initially for the fundamental concepts, right? Don't worry, I will manage the time in coming lectures also. That will be managed there somehow, because I'm teaching. I have plans how to teach to complete the syllabus in given time also. So don't worry about that. Just be with me, okay? So energy associated with motion is what? The kinetic energy, right? Okay, you said, sir, if something is in motion, so that will be considered as energetic also. So, why we are calling it a kinetic? That should be only the energy, right? Because there are some other kinds of energy also. That's why we are giving a name to this particular. So, how the other kinds of energy can be? Only kinetic energy or energy should be there, which is associated with motion. So now I will tell, okay, dear, what you have observed at rest in my hand, you are saying it's not energetic, because yeah, based on experience, that it is applying force, but it can never cause displacement with that force. That's why. Okay, so let me take an example. If I will take an arrow and bow, right? If I will pull it towards your mouth, if I will pull it towards your face, would you like to come in front? What's the problem? You will feel fear, but I'm asking, what's the problem? That arrow is stationary. What it can do? Nothing. Just by maintaining its rest condition, it can do nothing, right? So why you are feeling fear? Okay. If I will take a use a stone in my hand, if and I will tell you, just come and lay down just below to this. Would you like to come? You will say, no, sir. It's very dangerous to come below to that. Why? That stone is stationary in my hand. What's the problem? So problem is not that it is at rest. Problem with the possibility that it can come in motion if some unbalance will be caused, right? So you are feeling the fear of possibility, right? Possibility to come after some time due to some cause of unbalance in the forces, that it can come in motion, and here it's very dangerous, right or not? So possibility, probability, such kind of things. If I will say, or you have a huge possibility to crack the IIT-JEE, in other words, what can I say? I can say you have potential to crack IIT-JEE, right? Hmm? But you're not cracking right now. Some ability which is stored, hidden in you, it's not visible. You are not acting at the moment, but it looks that you will perform in future. It looks some capability which is hidden in you, right? Such kind of things will be considered as potential, right or not? So this stationary object also have potential to move, right, after some time, just by causing some kind of unbalanced, right or not? So this stone, this huge stone, is going to be felt as very dangerous. Why? Because of possibility, because it have a huge potential to cause destruction, right? In future, not today, so then in future definitely someday it will come in motion, right or not? So it have what? Not the real current energy, you can say it's something hidden, silent, in the sleep mode or dormant form of energy present in this, right or not? Are you getting this point? So yes, the stationary objects also have the energy, right? That's why you are feeling fear with the pulled arrow. Okay, so this is another kind of form of energy which is in the stored form, potential energy. So tell me, potential energy is the energy which is associated with rest? Yeah, because with the motion, the kinetic energy, and another state which is the rest state. In this, we are calling it potential energies. No, no, no. Let me take one more um, situation. If I am taking a stone in my hand in this way, you are feeling fear. But if I will raise this stone little bit higher, will you feel more fear? Yes. Will you feel more fear? Yeah, you will say, yes, sir, I will feel more fear. But I will ask them, here also it was stationary. Here also the same stationary condition. The stationary condition is not changing. Then why potentiality becomes more? Why it becomes more dangerous? So you will say, sir, no, with the rest it is not. But with the location somehow, with position, this energy is associated. Similarly, if I will pull the arrow in the bow, and if I'll pull it more harder, so I'm just stretching the string more and more. I'm taking the arrow little bit behind and behind. I'm changing the position. That's why it becomes more and more dangerous, right or not? Are you getting this point? So energy is what? The potential energy is what? So it is energy associated with position. You can say relative position, right? But just see this in a simpler form. I will go a little bit in more accurate manner also. So energy associated with position. Okay. So these are not new things. Already you had experience about these things, but you were not aware that we have called such kind of things some with some name, kinetic potential, energy, ability, work, right or not? Okay, so now you have a clear idea based on your experience. We have understood why such kind of definitions was like that, right or not? Because we have picked all these concepts from our day-to-day life, right or not? Okay, so now let's talk about a little bit much in detail manner work, right? We have understood activity in which something or someone forces some other thing and causes displacement. So with that force only displacement should come. Okay. So with the development of physics, okay, everyone have, let's say, understood that what the work basically. Then next thing was, the question was coming in the mind, if someone who is doing some work, so they are asking how much that person is doing, that thing is doing. Such kind of question is coming into picture. How much, if work is being done, so how much work is being done? how much, how many. If such kind of questions comes, then through these questions only the maths enter into the physics, right or not? So math associates with the physics here. Now you will see what the importance of maths here basically. So it comes to answer the such kind of question, how much is that thing? Okay. So because now I'm taking a demo already, because if I take some class from the beginning, so I inform how to give a amount to anyone in the unit and dimension chapter also. But because you are new for me, so I'm going to share all those idea how we will figure out how much the work is going to be done, right? Based on that only you will understand the depth, the complete picture of that formula which we are going to present. Are you getting or not? Everything will be understood behind that formula. Are you getting or not? Okay, let's talk about this. Mathematically we are going to talk about work. In terms of maths, we are going to talk about how much work if someone is doing. So how much work he is doing, how much work he have done. For that, if you want to give some amount to some quantity, so we have to select some quantity to say some amount. Let me explain. If this mobile having some weight, right? I'm feeling the weight in my hand. Let's say mass I'm talking about. So how much the mass it have? What we should say, what we should do. So before giving some idea what the amount it is, I have to decide, I have to select a some amount to call it something. And generally we select some amount to call it some with some one value, right or not? So let's say this pen is lighter. So from today, I'm going to choose this what experience I am experiencing, what the mass experience I'm experiencing. From today, I'm going to call this experience of mass with some amount, and that amount I'm considering 1 gram. Let's say 1 gram this pen is having. I have selected to call this mass with some value, right? So I have just chosen that it is now 1 gram. And I told everyone, okay, this much will be the standard. We call it unit, okay, right? So this much is the standard actually for everyone. Okay, this much will be considered as 1 gram. So then we can say the two pens will be there in my hand. So how much then? It would be the 2 gram. If three pen will be there, then you will say 3 gram. Similarly, other extents and amounts will be automatically defined. There will be no requirement to catch those things and give some name with that. Like every human being have different name, but the quantities doesn't required. If one particular amount is going to be uh, considered with some value, the others will only directly get identified with some amount, right or not? So understood. Okay, so we have to just select some extent to call it with some amount, right or not, to define how much someone is doing work. So here the Joule come into picture. He selected what kind of unit work will be. So he said, okay, work means someone is doing some applying some force and causing some displacement. So more and more force, more and more displacement, more and more work will be there. So he just defined in terms of force and distance. He defined that 1 Newton, if someone is applying 1 Newton and causing 1 meter force, of causing 1 meter displacement, then with this, whatever activity the person have done, that would be considered as the work have been done to change how much energy? 1 joule energy. So the for changing the 1 joule energy, what the work is required, that will be considered as the standard, the unit amount of work, right or not? So the work which can change 1 joule, that is the unit work. Okay, we understood now. Now let's talk about if some 2 Newton force is going to act to cause 1 meter displacement. It's a basic maths which we do in day-to-day life in every purchasing something, right, on the shops. So we are very well aware about this maths. So it's very simple. So 2 Newton will cause 1 meter. So what will you say? How much the work have been done? So I will say, okay, the work which can change the 2 joule energy, That much work we have done here. Now let's talk about if F Newton force will be there, 1 meter displacement, then what will you say? I will say, yes, F Joule. We can clearly see that. Okay. Okay, so F Newton force causing 1 meter displacement. So you are saying F Joule energy is going to change due to the work, right? So how much if I will apply the same F Newton to cause 2 meter displacement? So for 1 meter displacement, it was F Joule. So for 2 meter, it would be 2 F Joule, right? Okay, so F Newton force, if it is going to cause d meter displacement, so what will you say? You will say, sir, it is F into d, like this. We are just now creating a formula of work. We got that, right? What the formula here then? Have you seen that in class 9th also? Why such kind of formula is there? Lots of students ask that. So why we are multiplying? Why we are not adding? Why we are not subtracting? Why we are not dividing? Why the multiplying the two quantities gives the amount of work? Or similarly, other quantities also like force. Force have mass into acceleration. Why is such multiplication gives the value of force, right? Now you are getting that. Because work, how much is there, that depends on what amount of force you're applying, what amount of displacement is being caused due to that force. Because it is depends on that, we have selected the unit, and a unitary mathematics come into picture in this to give such kind of result, right or not? We got that idea. Okay, so W is the work here, how much it would be if F force and d meter displacement will be caused, so it would be F into d. Okay, something is missing in that. Let me uh, come to the points slowly. Let's talk about an example. Something is missing still in this. Let me show that. A block is there which is having mass m, right? And you are applying a force of 4 Newton, let's say, and here 2 meter displacement is there. What will you say? You as the 4 Newton is acting and the 2 meter displacement is with which it is moving in forward direction, how much this 4 Newton is doing work? So work due to this 4 Newton, what will you say, sir? As you told 4 Newton and d meter displacement, so it would be F into d. So here it should be 4 into 2 then. It should be 8 joule. Okay, it's wrong. It's wrong. Actually, it is 0 joule. Recall the definition of work basically. What was that? The thing is that if someone is applying force, so displacement should be caused by that force only. And let me give you one note point. A force can provide its effect in the same direction only. A force can provide its effect in the same direction only. Now that you will start saying, sir, if someone is moving with some velocity in this direction, a force is acting perpendicular to that, so it can cause change in velocity. Of course, here the force is acting in this direction, it is causing some velocity in this direction. The new velocity is something, let's say it is v dash, and this v together it becomes a resultant velocity in this direction. That's why it is changing. So what fundamentally the force is doing? Force is just causing its effect in the same direction, along the same parallel to the direction, we can say also. Okay, so this force, what it is trying to do? It is trying to crush the block, and in the same direction along the same line, vertical line, the displacement is not taking place. So we can say the force is not displacing by any amount, right? This 2 meter is due to some other regions, but not due to the, not caused by due to this 4 Newton. Are you getting or not? Not caused by this 4 Newton. So we can simply say 4 Newton is not doing any work. But if I will call this, if I'll show this 4 Newton and here 2 meter displacement, then what will you say? Yeah, now you can say that, okay, this 4 Newton definitely is causing work, causing displacement. So we can say 4 into 2, that would be 8 joule work is there. Okay, now it's fine. So what is missing in this discussion? The missing point is we should take only that force which is responsible for this displacement, or we should take that displacement which is being caused by this force. Or are you getting that? So the force and the displacement both are interrelated with each other, right or not? So here, I hope you have understood, right? That which force we have to take. The force which is really causing the displacement, right or not? Here the 4 Newton is not causing any displacement. So 4 into 0, that was giving 0. joule. Here, definitely it's 2 meter displacement due to this force only. That's why it is 8 joule. Now let's talk about one more case here. I'm going to take a block. Okay, I'm taking a block here. Now, if this block is experiencing a force in this direction, let's say it is something F, and it is having some direction I'm showing with the angle theta with the horizontal, and this is moving in this direction with the d meter, what would you say then? How much this force is doing work? Okay, so you will say that with the basic understanding, you will say, sir, force is acting in this direction, but in this direction there is no displacement. It is moving, but it is moving in the horizontal side. It's not moving at some angle. So I will say, actually, it is moving at angle also. Let me give some example, because already I have discussed in the vector. Those students have studied my vector lecture. They understood. They know what I'm going to say. Let me give some example. This d displacement is not only the d. It it is the mix. It can be seen as the mixture of two things also. Let me explain. Okay, here if I have a 2 kg block in my hand, if there will be 3 kg block in my hand, what will you see? Will you see according to your point of view? You will say that, okay, sir, I can see 5 kg is there. That's perfect. 5 kg. But maybe there will be someone, they can say, sir, I can see 2 kg and 3 kg. In this manner also, that person can see this 5 kg as a 2 kg and 3 kg also, right? Of course, that's fine. Okay, so here also, if I will take another case, like I'm taking a red color here and I will mark with the black color also at the same spot. So it becomes some kind of different color. Let's say I'm mixing two colors basically. So it becomes, let's say, brown after mixing the black. What will you say? What is visible for you? So you will say, sir, it looks brown simply, but someone else can also say that is black and red, both are present there. In this manner also we can see, right? But it's visible brown, but saying black and red is present is not wrong. This is also correct. Are you getting that? So there are two things collectively become something else, but we can say that is the two things are present, like this 2 kg and 3 kg. Based on our requirement, our point of view will be decided. Like if there will be 3 kg in my hand and 2 kg in my hand, if I will ask for, give me, bro, if you have some heavier mass, so you will say, okay, I have this, and you will see this complete thing as a 5 kg, because you have to give a heaviest possible mass to someone, right? Now, if that person will ask for the lowest possible mass, if you have, please give me, then you will see, okay, these are the 3 kg and 2 kg. So you will see, okay, this you will see in the two different, as a two different blocks, because you have to take a smaller one. So you have to see in the two, a kind of two blocks are present, right or not? In this manner, you will see. Okay, so you got the idea. Okay, one thing can be seen as the mixture of two also. So here d meter is not only the d meter basically. In the d meter there is hidden two displacements. Let me show that. One displacement I'm going to show along the direction of force with the angle theta with the horizontal, because it is moving in horizontal and force is acting along some angle theta with the horizontal. So here in the same direction I can give idea about a displacement. This is d cos theta, and you have studied in the vector chapter, right or not, d sine theta. So you can see the d meter as a simply d meter, or you can see as a d cos theta and a d sine theta is there. Two kinds of displacement is there. Now it is asking the question, tell me how much the force, this force is doing work. You will say, okay, work is depending on the force value and how much the force is causing displacement. And you know, force can cause its effect in the same direction. Of course, it can cause in the opposite direction. That displacement will be considered as negative. I will come on that. Don't worry. I will, when we will see the negative displacements kind of term, there I will explain. First of all, based on your experience, let's do how much the work is there. You will say, okay, force is acting F, and how much this force is causing displacement, because it can cause displacement in the same direction. So it would be considered as F d cos theta, right or not? Simple, right? This is what work due to this F. Clear. F d cos theta. You are not taking just d, you are taking that displacement which is caused by the force. Understood. Okay. Now, the same thing also can be seen in another way, like I'm taking the same here block which is having mass m. Now I'm applying the force F. Why why the D is only going to be seen as a mixture of two? We can see the force also, right or not? We can see force also as a two kinds of mixture of forces, right or not? D meter, and this is what F Newton force. Of course, it's more easy to see the force here as a two kinds of force are there, right? If some force is acting along this angle, so you are saying, okay, it is trying to take it in the along the inclined direction, right or not? Okay, someone can also feel in this manner that this force is trying to crush me something, sir, and this force is trying to take me forward. So this force have two effects, or you can say the two kinds of forces are acting, sir. What kind of forces? One force is causing or trying to take me down, and another force is trying to take me forward, right or not, along the horizontal direction. So yes, you are correct. This force is not only F. You can see this F as a F cos theta and F sine theta. And if someone is asking how much this F is doing work, so I can say, okay, you are asking how much this F cos theta and F sine theta together, they are doing work, right or not? Calculating how much the work done by this F cos theta and F sine theta is equivalent to calculate the work done by this F. You can say that. So I am not observing the F as a single F. I am just observing this F is the mixture of this F cos theta and F sine theta. So let's talk about the total work done. So I will say, okay, this F cos theta, of course, it is acting and it is causing some displacement in the same direction. I can see it is D. But what about the F sin theta? F sin theta is acting, but it is not causing any displacement in that direction. So it would be zero. So simply the whatever work is going to be done by the F cos theta, that will be considered the total work done by the F also, right or not? F cos theta into D. So here, what is this D? This is the displacement along force, right? And what this F cos theta, this is the force along displacement D, right or not? Clear, everyone? So this is what we have. So we have defined a beautiful expression for the work. Basically, we have written in this manner. If someone is going to ask, okay, if there were D displacement and force is acting with value F in some other direction, so if they are going to ask how much that force is doing work, so definitely I will take the force and the displacement in that direction. For that, we have made an expression. We call it dot product of two vectors, F dot D. What it is saying to you? Dot just simply giving you idea that, okay, we are not going to multiply very ordinary manner. We are going to multiply the magnitudes, of course, the magnitudes of two vectors, but those vectors, those who are along this the vectors, those who are parallel, right or not? Or you can say the vectors, those who are in the same direction. Basically, if some vector is opposite to that, so it would be considered negative. Understood? So F dot D, the dot is giving you idea. Don't just multiply F and D. Multiply just by looking into the details that which quantity I should multiply with the F. The quantity of D, I will take that which is along the F. I will take that value and multiply with the F. Understood? So this way to say F cos theta D, this looks bulky little bit, or you can say F D cos theta, right? So this is having the same meaning. Basically, this is just represented in this manner. It's a way of representation, nothing else, right or not? I hope you understood properly. Clear? Okay. Now let's talk about something else in this. Okay. It's not the complete definition of work. Something is still missing. This formula is only applicable if force is uniform, or you can say constant. Constant means direction and magnitude both should not change, right? Both are, you can say, constant. Then definitely you can multiply the complete D, because force is acting for throughout the journey of d displacement, so definitely it would be directly multiplied using that unitary method, right or not? But what will be the problem if, let's say, for each 1 centimeter, new force is going to come to apply and to cause work, to do work. So for 1 centimeter, let's say if some force is acting continuously as a constant value, so it's fine. Then for 1 centimeter, we can calculate how much work is going to be done. Then for next 1 centimeter, we can calculate a separate work then just by taking that new force, right or not? Again, in similar way and so on. So for coming displacement 1 centimeter, for each 1 centimeter displacement, I will calculate a small piece of work, and then we have to add them. Then there is nothing else to do, right? We can do only this because we have seen that mathematics, what was this involved, that mathematics was the very basic mathematics we do in our day-to-day life, right? So if you will think from the basics, so you will find that, okay sir, we have to add then if for each 1 centimeter forces are going to be changed, right or not? Okay, not only let's say 1 centimeter, if for each location from this position to the coming next position, if you will jump on the next position, you will find some other forces there, then what will you do? Again, here we will add only. So now, but we will take only very small displacements, right or not? For a small displacement, because for it's ds basically infinitely small, infinitesimal we say, this infinitely small displacement, for that a force was constant, let's say something f1, and this, for this it was f2. So for this we will calculate f1 ds, f2 ds, in this manner f3 ds, right or not? And we will add all of those, then we will get the total work done. So adding all these small pieces of work is very difficult. We call these pieces of work as dw. Manually we cannot add. What we will do for non-uniform forces, I'm writing here adding for non-uniform forces, what we will do, we will add all these small pieces of work, but adding of this is not manual. We call the process of addition of all this integration, right or not? F dot ds I'm taking because we don't know f will be in the same direction of that small piece of displacement ds or not. Are you getting this point? So in this manner, we will add and we will calculate the total. So this is the most general expression now. F can be constant, can be variable. All cases are going to be involved in the same expression. Understood? So now after addition of all these small pieces of work, you will get the total work done. Okay, so you are getting now idea that how these expressions are coming in picture, right or not? Okay. Now one more important point. This ds displacement, what is this? It's a displacement of complete body, displacement of object. In bracket I'm taking body. Is it the displacement of body? No, wrong. It's a displacement of point of application. Because if a force is acting, let's say I'm taking this bottle here, if force is acting at the top, we will show with the arrow, and the arrow have a tip, and that tip is only targeting the one single point here, right? So that force is concerned about what it is going to do with that point. It's a by default, because the body is rigid, so the whole body will follow the same motion. But the force is not concerned about the body. Force is just targeting that point only, right or not? So that force is just doing work on that point. Understood? So force is trying to displace that point only. So then who is targeted? That point is targeted by the force. So displacement of that point we will consider. Whatever is under the force, under the action of force, right or not? Understood? So be careful, the displacement of point of application. Let me give it one example. If a monkey is climbing in this manner, right, on the rope, if monkey is climbing, so if you will see that the hands on the string is not sliding, yes, during each step of moving up and up, the whole body is going up, but during this movement of one step, the hands, those who are grabbing that string, those hands are not sliding. Now the question will come, what the string is doing work? Of course, the string is applying some force and the body is going up. So string is applying force, that is the tension force. It is applying on the body or on the palms, you can say only. Yeah, on the palms, right? You will say, sir, yes, the tension is actually acting on the palm, right? And during the movement, the climbing of the monkey is going up and up in each step, but in each single step, you will see the only body, the other portion of body is going up, but the hands are not going anywhere. So in that duration, work is not been done by that tension because there is zero displacement of that targeting portion over which that tension is acting. Are you getting that? So tension is not doing any work here. So then how it is going up? His muscles is doing work. That's why he will feel tired after climbing by some height, right or not? He will feel tired because his muscles are doing some work to take it up. Understood. During walking, also the same situation will be there. During walking, in each step, if one feet is in contact with the floor, and floor is applying to forces, normal and friction. I'm talking about, let's say, friction, how much doing work. So when the one step you are taking, so the whole body will be in air and it will try to go forward. But in this movement, the feet, which is in contact with the floor, that feet sole is not basically sliding, right or not? That is stationary. The friction, whatever it's acting on the sole, with that friction, displacement is not being caused in that case, right? So we will say the friction is not doing any work in this case. During walking, also the same scenario will be there. So be careful here, right? So each and everything is very important in this discussion. Understood? Okay, so next time we will talk about some interesting questions also, as you have now a proper holistic understanding about the whole concept, what the work basically is, how such kind of expressions are coming, you know the story behind this expression. So in J level, they are not going to talk about this result finally. They will try to check the the meaning, the understanding, the idea behind this expression is what. And that idea, if you want to understand, so you have to go through this complete process, how this expression comes into picture, right or not? So in this process of explanation, you will get each and every point, details, and you can also imagine the meaning of this expression only, right? If I will go with direct term, I will write down, so maybe you will not be able to imagine the whole picture. You will imagine some blur, like if I'm talking about a face, and that face you are not observing directly from your eyes. So I'm saying lots of words related to that face, and just by listening that word, you cannot imagine the real sense behind that, right? What we should do, we should show you, right? See this. This is what I'm talking about. Are you getting or not? That's why I go through this approach to explain. First of all, these are the fundamentals. Let's take some time, whatever it takes. Then we will proceed further also with the questions. Also, you will understand if something you are missing in listening, or developing the meaning. If you are something missing, so with the questions also you will understand. But don't worry, the time, we are not getting late actually, right? Yes, we have taken this time here. With the time, I will adjust the times, right? I have taken lots of classes on that, so I know how to complete the syllabus. Don't be worried about that. Okay, so thank you for giving me time to see this lecture. I'm glad to share this explanation with you. So thank you so much. Thank you very much. We will meet again, I hope.